Well, here's a video looking at terminal velocity, which is often a really tricky part of the P2 part on the topic of forces in the AQA test. So here we've got a little bit of a review activity looking at the quality of written communication. So let's look at this exam question. It's 6 marks. So part A, the diagram shows the forces acting on a parachutist in free fall. The parachutist has a mass of 75 kilograms and they ask you to calculate the weight of the parachutist. Gravitational field strength on Earth is 10 newtons per kilogram. They give you the equation, of course, on the physics sheet, which is just the usual one of weight equals mass times gravity. That's the simple part. I think most people can get 3 marks. All you're simply doing is doing 75 kilograms of mass times by gravity on Earth, or the acceleration, which is 10 newtons per kilogram, and that works out at 750 newtons, and that's acting down. Now, clearly, I think again most candidates forget the idea that if you've just worked out this weight, unless you've been sick on the way down or you suddenly lost amazing amounts of weight or gained weight, you are going, of course, to be keeping the same amount of weight. Now, the QWC question then, it uses the graph. So vertical velocity meters per second, time in seconds on the x-axis. So the skydiver clearly accelerates and gets faster and faster and faster, even though the rate of acceleration is decreasing. Your velocity clearly goes up all the time until you reach a steady speed of 60 meters per second, reading off here. You're traveling at 60 meters per second and then you open the chute and suddenly decelerate. So we've got a negative gradient on the graph showing the acceleration is actually now, which is here acceleration, has become a negative acceleration or a deceleration. They even give you the picture there showing you that the air resistance has gone really big, so the resultant is changed direction and you are slowing down. You then eventually reach a new terminal velocity looking to be approximately 8 meters per second until suddenly you decelerate at 55 seconds and you land on the ground. Now, they ask you, using the idea of forces, explain why the parachutist reaches a terminal velocity and why opening the parachute reduces the terminal velocity. These questions are always phrased in terms of forces. The vast majority of candidates talk about it only in terms of velocity. Of course, that's why they don't get the 6 marks. Now here's one candidate. So it reaches a terminal velocity because no more force can act against it. Once the parachute is open, there is more force. So the parachute is slowed down. The terminal velocity is reduced. So I thought that one's worth about a mark. What force do they actually mean here? They need to talk about resultant force. Which direction the two forces are acting opposing each other, but what direction is the resultant in? Now, what force do they mean here? They say there is more force. Which force are they talking about? And here at the end, have they linked the change of forces as a pair to the terminal velocity? You have to talk about that both the forces are acting equal and opposite, which means that when they're in balance, you're at terminal velocity. Let's have a look at a second person. The parachutist reaches a terminal velocity because he knows something force working against him when he's falling, but when the parachute opens, a force of upthrust which slows the parachutist's terminal velocity down. So I've got lots of ticks here for the student assessment, but unfortunately I only found a couple. So we've got no or balanced forces there. We need again resultant forces in here. Full stop and a capital. QWC question should be thinking about this. And finally, how does it change? So a force of upthrust increases when the chute opens. We've got to talk about increases or decreases. Now let's look at a more detailed answer. Now this one I thought about 5 marks. So they've talked about here, so when the parachutist first jumps from the aircraft, their weight force is much greater than the air resistance force. And so from 0 to 15 seconds, so they've put something in from the graph, the parachutist is falling at a very fast speed until 16 seconds. And at 16 seconds, the two forces of air resistance and weight balance each other out as the parachutist reaches terminal velocity. This means that the resultant force is now 0, and so the parachute would be measured at a steady speed between 15 and 25 seconds to discuss the resultant force. At 25 seconds, the chute opens, and a dramatical increase in the air resistance of the parachutist means that the parachutist slows down, as the resultant force is no longer 0. So look at the things. Talk about one force is greater, then the forces balance causing terminal velocity. They discuss the idea of a resultant force, a big takes small, and then they discuss the big increase in air resistance. So there we go. That is my little quick video looking at QWC questions for terminal velocity.